C, is it possible for me to go back to a time before streaming apps?
Why would you want to do that?
So I can learn what the deal with cable was.
Hello.
What the cable? Hello, Ben.
I am here.
Thank you.
Cable where they plug up like the Cable Guy with Jim Carrey in it.
So what do you do now that doesn't involve cable?
Streaming.
Well, where do you think it comes from? What do you think streaming means? What do you think streaming means?
Space satellite.
It could, but streaming doesn't mean that. Streaming just simply means that you're getting something live. It's just a different word for something being live. Hey, I'm going to stream this. It just means that instead of watching a YouTube video, you're watching it live. So it's being streamed to you. Imagine electrons flowing towards you.
There was a buzzer war, and it was amazing.
I won. You did not win. I won.
Which class?
Mr. Catanello.
Clearly Hector was in the back.
The buzzer war was intense. Jack broke his buzzer.
What did Jack break?
His buzzer.
What did I break?
You trying to hit it too hard?
I think I broke my eardrums. Yeah, I can't hear.
So the buzzer has a certain time where you hit it, and then you have to wait for it to be able to hit it again. He was spamming it 3 times before he could be able to hit it again, so therefore he broke it.
What?
Was that the one Anna was using? Was it pink or purple?
It was pink. Purple. Pink
It was like magenta.
It was pink.
Pink purple.
I got to put another magnet on it. I don't think it stays up.
Well, I think this thing's long enough for the board.
No, it wasn't made to draw one from one side to the other.
Oh, okay. There's my quiz.
Jack, I'm sorry, Ben, you're talking to yourself.
Yes, I am. Thank you.
This stick, it's a nice stick.
I need it today.
All right.
All right, find your seats. Let's get things going.
Are we going to go over the worksheet or no?
We can, if we need to.
No.
Oh, wait, they're the answers.
No, the answers are on the last page. Do
Yeah, I know.
you need me to go over anything on the worksheet?
No.
Okay. Quiz is on Monday. Guess what the quiz is going to be on?
This corresponding to
That worksheet. That will be the quiz. So all I'm going to do is instead of giving you 20 of them, I'll give you, I don't know, 8 of them or something like
So
that.
can I take this to my book?
Yes,
group?
I'm not going to collect those. Those are for you to study for the quiz on Monday. There is nothing on that worksheet that isn't, everything on the worksheet will be on the quiz. Ben, you got that?
Yes.
Madison, I know you're not live, but Madison, everything on the quiz will be on that worksheet. All right. Quiz on Monday, and we're going to roll through this material.
But we only have 30 minutes left.
And I only probably have about 25 minutes to talk about. So it works
1
out
through
well.
10, okay. Ow.
All right, homework's on the board. Put it away, Jack.
Wait, I'm sorry.
I don't know. It's the largest book in the entire school. And they forget.
It can't be
Ours,
It's the largest book in the entire
ours
school.
is thicker for biology.
Is it?
Ours is like this thick.
But
It's
it's
like
not
a
this-
lot. I think it's about the same.
Probably about the same amount.
Science teachers want to show up the math teachers so the books have to be bigger.
Our biology book is very.
Wait, are math and science people always fighting?
It's like bigger.
I wouldn't say we fight.
Do you fight with history people?
What did I do with the, I didn't print off worksheets for you guys, or I didn't print off the sheets for today. All right, we'll get over it. I actually did, but then I had a lot of issues with, not like behavioral issues, but I had a lot of just mental and logical issues with period number 2. They really didn't get this today. Do not disappoint me. You're supposed to be the smart ones.
Is that okay if I support you?
All right. No, I literally, it was painful this morning. But I'm hoping that it's not the same with you guys. So sometimes I'm at a loss for explanations when when it makes so much total sense to me, like it just needs to be stated once. And it seems like such an obvious thing. And then I'll have people that will literally say they don't get it. And then that's when I have a big conundrum of, well, how do I explain it? What's there to explain? It's like saying your head is on the top of your body. Isn't that all you need to say?
No.
And then somebody says, well, where's the head? And I'm,
Teachers,
No!
this is your last afternoon reminder for attendance. Thank you so much for taking your attendance today.
Wait,
Lower school, please take your afternoon attendance. Thank you.
I didn't take my attendance.
How dare you? You should do that. Otherwise, the teachers will think you're missing.
No, it won't be the teachers. It'll be the admin. All right. Okay, here we go. No, I mean, if you guys are lost on this, you can be lost. I truly don't think you guys will be. And I don't mean to say that from, oh, I'm lost. Now I'm afraid to say I'm lost. If you're lost, just tell me you're lost. It's okay. I need to work on my ability to explain it a little bit better. All right. Congruent triangles. So this is kind of an application of the stuff that we got from the previous 2 days. I mean, this is probably more for average. I don't truly think this is a tough class. I think I need to show you about 2 examples, and it should be enough, but we'll see. So the big picture is this. I'm going to give you a couple big ideas. The first big idea, you'll be asked 2 things. First big idea, you're going to be asked to either prove that 2 segments are congruent or that 2 angles are congruent. That's the big picture. I mean, we're going to do a proof. Oh, by the way, everything's a proof today. There's nothing that's not a proof. We're only going to formally write up one proof, right? And we'll just talk through the rest of them. So you're going to be asked to either show that 2 segments are congruent or 2 angles. That's it. That's the first big idea. There's 2 big ideas. All right. So what you want to do is this. You're going to show that these 2 parts, either 2 angles or two segments, they're part of 2 different triangles. So you're basically going to be looking at 2 triangles, and then you're going to take those 2 triangles, and you're going to either use SSS, SAS, or Monday we'll get AES. But we don't have it yet.
What about ASS? There has to be one.
Yeah, but then you wouldn't be able to prove the 2 triangles are congruent. Okay, so you're going to use either SSS, SAS, or ASA to show that the 2 triangles are congruent. And then since those parts are going to be part of a triangle, then you simply say by CP, they're congruent. Because it means what? What does this saying mean? Not congruent, but corresponding parts of congruent triangles are congruent. So we're going to show that those 2 parts, either 2 angles or 2 sides, are corresponding parts of 2 different triangles that we just proved were congruent. Therefore, the last C, they're congruent. And that's how the proof is done. The proof doesn't change. It's done this way. It's just these 3 steps and you're done. So this was kind of the reaction from period 1. And I said that, and they're like, what do you mean? Okay, so here's what we're going to do. Now, we're not going to write a formal proof here, but I want to prove that angle A is congruent to angle C. So step number 1 is show that these 2 parts are part of 2 triangles. Well, what's the problem here?
You have to split it up into triangles.
We don't have any triangles, so what do we?
Yeah, you draw triangles inside the.
Okay, so how do you want me to draw that?
Like a
From where to where?
A to C. Or B to C.
If I drew it from A to C, what would be the problem with that?
Oh, you wouldn't have angles of A. Yeah, I wouldn't have angles.
Well, then I would break A into 2 parts and C into 2 parts. Now I got to do 2 more things, right?
All right, so
If I draw it from D to B, then I have A is on one triangle and C is on the other
then
triangle.
you can do side, angle, side.
Well, let's see what we could do. All right. So notice we're not given anything. Oh, wait, we are given stuff, and there's some numbers here. So we want to prove that I don't know if you want to call this the top triangle or the left triangle, and that's the bottom of the right, either one. I want to show that the 2 triangles are congruent.
Okay, then you.
So, well, let's see what we got. Somebody?
Well, 4 and 4 are parallel.
Okay, so what? Not parallel,
Oh,
but.
not parallel. They're congruent.
So what do you want me to write?
Congruent angle? No, congruent.
Congruent segment. So
Yeah,
tick
segment.
marks, right? So I could put a tick mark there and put a tick mark there, showing those 2 sides.
Yeah,
congruent.
the 9 and 9 are the same exact thing.
And then the middle is the 3 tick marks.
Yeah.
Why?
the middle's-
Because it shares one side.
Because it's what?
Because it's sharing a
Sharing.
side.
Because it's what?
Sharing a
Share.
side.
Because it's what?
Because it's
Adjacent
vertical.
angle. Adjacent triangle.
Because it's what?
Vertical.
Reflexive.
Thank you. It's reflexive. You got to remember that thing. I mean, we're going to be using this reflexive property a lot. So are those 2 triangles congruent?
Yes.
Yes.
Why?
Because of SSS.
Okay, so then you prove the 2 triangles are congruent by, in this case, SSS. Now you need to write a congruency statement.
Well, as DAB is congruent.
You got to be careful. Now, he can choose any 3 letters. he chose D, A, B. Now, check it out. I go from D. D is on the side of 4, and I'm going up to the side of 9, and then across the 9. So we got to do the same pattern. We got to stay on 4, go up to 9.
Which is DAB is congruent to BCD.
So B, C, D. I don't think I wrote it that way, but you get the idea.
All right, then you can use.
I think I probably wrote A, B, D or
Then
something.
you can use one of the
Oh,
theorems.
hold on. So there's my congruency statement, right? We're trying to get that A is congruent to C. Can you prove it from here?
Yes, because A.
Why?
Because of some theorem that I'm looking up.
5 letters.
Oh wait, yes.
CPCTC.
Because of CPCTC. So now you claim congruent parts of congruent triangles. You just showed me that triangles are congruent. So I said congruent parts, corresponding parts. So what corresponds with A goes with C. So that's what you're really doing. So now we can claim that A is congruent to C because of CPCTC.
How do they find this hard? I mean, it's just a regular proof.
I spent 5 minutes on reflexive. Like I had kids it couldn't tell me that side was congruent to itself, and then they were lost on what does it mean that it's congruent to itself. Oh, I'll play the video for you. If I have time, I'll play the video for you.
Oh, cool.
All right.
Oh, cool.
Cool?
Yes,
All right.
makes perfect sense.
So these are the 3 steps for showing parts are congruent to other parts. It could be angles. It also could be sides. So here's one with sides. I spent 10 minutes on this one just getting past the given.
Well, they're vertical. That's good.
Where do you see vertical?
Not vertical, they're reflective still.
Yeah, I absolutely see a reflexive. What do we get from the given?
PQ is congruent to PS.
So I could put tick marks on PQ and RS, yes?
Yeah.
And then PR bisects QPS.
What does that mean?
Which means that if. Oh, I know. So it means
Let the
that
girls talk. You guys are. What does it mean? Which angles? There's no alternate interior here. Alternate interior would be 2 parallel lines cut by transversal. What does it mean to bisect? Use any words you want. What does it mean to bisect? If I bisect something, so you make what? 2 different or 2 same parts? What did I make the same? Doesn't say it bisects a triangle. What 2 angles? And what can we say about them? Okay, so that would be my first statement. I could say that QPR is congruent to SPR, right? Because that's what bisect means. It means it cuts it in half. All right, so we can say that simply by the definition of an angle bisector.
Then we have reflexive.
Well, let me get some marks here. So we got that.
Then we have reflexive.
Well,
Reflexive.
we got that part.
Yep.
That's the given. And then we have, what was the other thing?
Reflexive.
Reflective.
Okay.
And then you know that by SAS, then it is congruent.
Is it
to
SAS?
Yes, through
SAS.
CPCTC.
Okay, so then we know that I shouldn't do that. Give me the triangle congruency.
QPR is
So stop with that. So as soon as you say QPR, you just got to notice the pattern that you made. There's no numbers now. But we went down the side with 1 tick mark, past the angle that we said was congruent to the one with 2.
So then
Yes, that was
QPR is
true.
congruent to SPR.
Yeah.
Just be careful. You can write that. And if you write that backwards, you're going to come to the wrong conclusion.
So then
And that's because of what?
that's because of
That
CPCTC. No, SAS.
Okay.
And then
And
you
what?
know that Q is congruent to S
Because,
of CPCTC.
and it matches for Q goes with S because of CPCTC. Cool? All right. One more.
Okay.
Okay, so
No,
wait, that's the same exact one.
it is literally the same picture, but it's not the same given.
Oh, wait,
And
yeah.
it's not the same
It is
proof.
the same.
All right, Anna, tell me something.
bisects QPS.
No, that's literally what it says. But you got to give me something because of that.
Angle QPR and RPS are congruent,
Okay, is that the only thing it says?
and angle QRP and PRS are congruent.
You said it a little bit. If you call this QRP, then you might want to say SRP. But what you said was fine. I wouldn't mark you wrong for that. Okay, so she said basically that right there. And why is that the case?
Because of the definition of angle bisector.
Definition of angle bisectors. Okay, so let me mark that. That's congruent to that. I gotta put two. Those are horrible. Ignore them. All right. Yes.
So it's angle
And
side
then
angle.
and then
Where are you getting a side angle?
Well, because of the reflexive.
Oh, okay. So PR is, you can't forget to make that statement though.
Well, can I skip over it? Is it possible?
Yeah, so
like
I mean, in
substitution?
high school math, they're going to want you to make that statement, even though that we could already, well, it's obvious, it's reflexive. Clearly not in period 2, right? It's not. They don't know that yet. So let's just go ahead and make the statement. All right.
Okay.
What now?
RP.
No. I need the triangle congruency statement. So she went Q down to the single arc over to the double arc. So QPR is to SPR. And what was the reason? Okay. And then we can immediately jump to, and let's just make sure it's right. PQ, that would be middle first, PS. Wait, that says RS. Did I make a mistake?
You might.
Because RQ is congruent to RS.
Yeah, I made a mistake. They should say PS.
All right.
I made a mistake. Why didn't I catch that last year?
Why didn't you catch
Why didn't I catch it in period 2? All right, these are not the droids you're looking for. That should say PS, not RS.
All right.
PQ is not congruent to RS, by the way. All right, that's a mistake.
I mean, or it could have been RQ. So
Cute, yeah.
just getting P's and R's.
It could have been. It could have been. Yeah. Yeah, if I changed that P to an R, it'd be easier, wouldn't it? Okay, so that's how you show that either sides or angles are congruent to each other. You put them in 2 different triangles, show me that the triangles are congruent, and then you just simply state CPCTC and you're done. Okay, so second big idea is this. It's the same general idea, except instead of showing that either angles are congruent to angles or sides congruent to sides, we're going to show that we want to show that 2 segments are parallel to each other. Okay. Well, last chapter we had 3 different ways to show that sides are parallel to each other. So how do we show that sides are parallel to each other? This side is parallel to that side.
By the parallel symbol, which is
The arrows.
Yeah, arrows. Yeah, arrows.
Oh, no, I don't mean that. I mean, how do I prove that this is parallel to that?
What's the board
Depending on alternate interior angles.
So I got to have a transversal, and then what? I have 3 different ways.
Corresponding alternate
Oh, yeah,
interior.
Corresponding or
Alternate interior.
or
Same side
same
interior.
side interior
Same
supplementary.
side exterior.
All right.
Same side. Like just lots of them.
Well, it's really just 3. The others are just carbon copies of the alternate exterior is basically alternate interior. All right, so yeah, and oh, by the way, to do this with triangles, it's always going to be alternate interior, almost always. So what you'll do, you'll show that the 2 sides that are parallel, that you're trying to prove are parallel, are parts of 2 different triangles. Show me the 2 triangles are congruent. Claim that this part is congruent to this part, and then show me that either alternate interior, we don't have alternate exterior.
So it's
although-
just the same as the first one.
same as the first, except that the final statement is that the reason why they're parallel is because of, I don't know the theorem off the top of my head, but the one that states,
Theorem 3-5.
is it 3-5 that says if alternate interior angles are congruent and 2 lines are cut by transversal, then the lines are parallel. If that's 3-5, then it's 3-5. That's certainly a lot shorter than the way you'll see me write it. Okay, and once again, some people are clueless on this. So this is what it will look like. All right, McKinley, you're up first. And I'm going to write this one in a full-blown. This was the only one that we were going to do full-blown. So we're writing a real proof this time. The other ones, we would say it's a talk-through proof. We're just going to talk through how the proof would be written. So what do you want me to write?
By AB bisects.
Okay, so that's the given.
Which means that AB C bisects CBM. No, wait, that wouldn't work.
Well, it does. It says
CMD,
bisect each other. So
CMD. There we go.
say it again.
AMB bisects CMD.
What's
Right,
what's AMB? What are you trying to say?
I'm trying to say they're congruent.
What parts are congruent?
I'm trying to figure out how I would.
So if they bisect,
it would be ADM and then CBM.
yeah, but you're giving me 3 letters. 3 letters are for angles.
Oh, triangle. Yeah.
It doesn't say anything about the triangles bisecting each other.
Oh well, then those are. I don't know how to.
What
word
does
this.
bisect mean?
That they're equal to each.
It does, but what are equal?
Those 2 angles. those two segments.
No.
No, not angle. They're
Well, it
that
might
is
not be true.
Yeah, that is.
No, it might not be true. Hey, check it out.
Yeah.
Here are two segments
Oh, wait.
that bisect each other. Those segments are clearly not congruent to each
No,
other.
I'm saying I'm saying that the top one is congruent to the bottom.
Yeah, I think
So tell me what you're really trying to say.
They're bisect. M
Use
is
some
mid-
geometry stuff.
M is the mid.
Okay, what does that mean?
It means that
Say
M
it.
is congruent to MB and CM is congruent.
No, you guys are way off. He's right. Go. Say it again.
AM is congruent to
All right. So if this cuts it out, well, you didn't say it.
Yes, I did. I said AM is congruent to MB and CM is
We're
congruent to
being
MB.
recorded. We can play it back.
No, that's what I said. I literally just said that a minute ago.
I don't think so. We'll play it back. Say it again.
segment AM is congruent to segment MB and segment CM is congruent to
McKinley, was that what you were trying to say?
I was thinking something along those lines, except I was going to say AB and CB are congruent to each other.
But you see this picture?
Yeah.
Here are two segments that bisect each other, and it could be true.
Now I get why
right?
that would be wrong.
But what she said was what we want to say. And what's the reason we can say that?
Because of
definition.
That's the definition of a bisector cuts something in half.
All right.
And the consequence of that is you create two congruent parts. Why are you not clicking?
It's doing the line.
Oh, it's doing the line. Oh, duh. Okay, thank you. You're paying attention. I'm not. All right. So we good?
Yes.
McKinley, you're up.
All right. So you can.
Oh, and period 2 got this immediately, by the way.
Side
After this,
angle
not
side.
this, but the next one they got immediately.
Yeah. So side angle side, you can prove that because AMD is congruent to CMB
Because
because of side angle side.
no,
No, because of
you're so close.
the vertical angle.
Thank you. All right. And they got that immediately as well, too. And like I said, you're always looking for that X. You see an X, you got vertical angles. All right, but you were going to say what after that?
The ASA. That's what also.
What are you saying?
ASA.
What are you
Angle-
saying?
No, side angle side. Sorry.
All right, give me the congruency statement. And it doesn't matter which 3 you pick, just pick 3. She went ADM. So if we go ADM, we're going no side with tick mark to 2 side to 1 side. So no side to 2 side to 1 side. So yours is ADM is congruent to, yeah, that'll be right. I don't think I wrote that, but I wrote AMD, but you get the idea. And that was true because of SAS, okay?
I think you just did that
So-
because then you could copy the previous thing, AMD.
Probably, right. Now here's the new stuff. So we're not going to say one part is congruent to another part. We're going to pick a specific part. Notice we're not trying to prove any parts are congruent, trying to show things are parallel. So here's what I suggest. Scratch work off to the side. Which sides we're trying to show that are parallel?
AD and BC.
So imagine them as the lines, right? So I've got this line and this line. I need to show they're parallel. Well, they're cut by 2 transversals, either this one or this one. Pick one. Which one you want?
CD.
All right, so we're picking that one. Where are the alternate interior angles?
C, angle C. and angle
This
B.
one and this one. So now you got to tell me what that angle is and what that angle is.
Let's see.
That's M, C, B, and ADM.
Or you could just say angle C and angle D.
Oh, yeah, even easier, wouldn't it be? All right, so yeah, angle C. Well, no, because where's angle D?
Just right there.
That's right there.
Yeah, but that's, oh, yeah, you're right. Duh. Never mind. Okay, so, oh, by the way, that's what I did as well, too. And they're congruent because, well, now we could have chose the other one, and then it would be that angle and this angle, okay? And the reason why we're choosing those is because of that theorem 3.5, apparently. Because if you show that 2 lines cut by a transversal have alternate interior angles, then you can claim that the two sides are parallel to each other. Clearly, writing 3.5 is quicker than that. But I don't have them memorized. I mean, besides postulate 1, 2, 3, 4, that's where it ends for me, right there.
It ends for me after one.
Well, what is postulate 1 now? You got to prove that
Well, I
part.
do know postulate 1 is the ruler postulate.
Yeah,
Well,
ruler
you
postulate.
proved it for you, but not for McKinley.
Ruler postulate.
What's the second postulate?
They're congruent.
segment by
Segment addition.
segment addition postulate. And then
And
the
the-
third is the protractor
Protractor
postulate.
postulate.
Fourth is the angle
Angle
addition
addition
postulate.
Okay. Okay.
No.
Last one.
I hate these.
I do not like these.
All right. So it's the same thing. I mean, we're just trying to show that two things are parallel. Which
Well, let me
ones?
just repeat the last one. and
Okay, so
change
tell
the
me what to
numbers.
do.
Okay, so those two are congruent.
What two?
The given. You write down the
Okay, so
given
what do you
ones.
want me to mark?
So WX is congruent to DW and XY.
Make sure you're
So they're
marking.
equal to each other because of some sort of
Well, let's just stick to congruency.
the congruency.
What else? There's my 2 tick marks.
That DW is congruent to XY.
Okay.
Then there's the reflexive one in the middle, which gets you,
I didn't make a mark there. I should have made a mark.
which means you can do side SSS, which is
You got to give me the triangle
ZWX.
congruency statement.
Triangle congruency.
Give me the triangle congruency statement.
Oh, WX is congruent to YZ.
Triangle.
ZWX.
Okay, so he went, hold on. He went ZWX. So you went 2, 1, and
2, 1, none.
2, 1, none. Right.
So it's ZYX.
2, 1, none would go
YX. No.
X,
X,
Y,
Y,
Z.
Z.
All right. I don't know if that's what I chose, but I didn't. Okay. But you get the idea.
No, you didn't. That was the one that he
Okay. Now, which ones are we trying to prove that are parallel?
WX and ZY.
So I'm going to draw WX that's bottom and top. Okay, well, we actually have 1, 2, 3 transversals here.
Well, let's just do ZX.
I would agree. The easier one is this one. And where's the alternate interior angles?
Well, there's
1 and
Z.
2.
I mean, yeah, that one.
That's
and two.
1 and 2. So,
I mean, 2 and 1.
so here's the only problem. Just because we think that they're congruent, they may not be corresponding. We got to make sure that this angle and this angle are corresponding. Well, this angle, although it's labeled 2, our triangle congruency statement doesn't have a 2 in it. So we got to make sure, what is this angle right here?
That's Z.
It's half of Z.
Yeah, we got to give it a better name.
It's half of Z.
So it's XZY or YZX. So it is, let's say it's Z. And where's 1? 1 is, are Z and X congruent?
Yes. No, yes, they are.
No,
not
see what I mean? It doesn't work that way if you use one letter for this particular drawing right here. So we just got to make sure they're congruent. Well, let's see.
So ZY. And
So YZX is which angle? YZX is which angle?
It's 2.
2.
It is 2. But I'm saying we got to show that this angle is congruent to that. So
Well, it's just.
Yeah.
did we make a mistake here?
No.
I think we might have.
Well,
Let's see what did I do. I did W, X, Z. So 1, none, and I gotta go 1, none. 1, none would be Y, Z, X. I got these backwards. I got those backwards. Y, Z, X. I didn't catch that first period. Okay, so now does Z go with X?
Yes.
Yeah, Z goes with X over there. Okay.
Yay.
Whew.
wait, what?
So SSS, therefore, 1 is congruent to 2 because of CP, therefore you can claim because of alternate interior angles. There in 5. Okay.
All right.
I gotta change that. That's 2 mistakes.
Which I caught, so I
caught-
get +2.
No.
You
He
caught-
caught, Mr. C caught both of them.
But I caught one last week, and you still haven't got me a point for it.
What did I make a mistake last week?
You made an error on the writing.
Oh, right. Oh, that's gonna happen. That's gonna happen more than once.
It's still a mistake.
It's not a math.
All right.
So it doesn't really matter.
You didn't put this in your book of truth.
Uh,
What after my demonstration? Here it is. Okay. So here's what it's saying. Here's your plane. And here's a line, and it's perpendicular. Yes. So this line and this plane are perpendicular to each other. That's the basic step. Look at this. Look at this. Yes.
Yes.
Now I'm going to get rid of the stick here. I'm going to draw a line through this hole on the plane. So it's going to go through the hole, but it's on the plane.
Okay.
What's the relationship now between the stick and the line?
Perpendicular.
Okay, I'm going to draw another line through the hole, not the same line. What's the relationship between the stick and that line?
Perpendicular.
So what's the relationship if this line is perpendicular to the plane? What's the relationship between any line that goes through the intersection point?
Perpendicular.
That's what it says.
Well, not any line that goes through the
Any line that goes through that's on the plane.
Right. You said
Yeah.
any line that goes through.
Yeah, we need to add that one caveat there. That's on the plane.
Yay, we're finished.
It's through the intersection point, and it does. Somebody open up your book and tell me if that's how it reads in the book, because it should say on the plane. Because it doesn't say it here in this
So
definition.
wait, that's a point for me then. Because it's
I
on-
give you a point for that. I give you a
Yes.
point.
But I
But-
don't get a point for making out.
It's got to, if the book has on a plane, then I'll agree I left that part out. But if this is how the book is written, then we're going to say that both of us get a point for that one.
Okay, take it. I will take the point.
Can I pay my watch to get free food at a restaurant?
You can, if you have an Apple Watch.
But I don't have an
Except it's
Apple.
not free, you're just paying for it with your watch.
But yeah, I paid for this with my watch.
That's
It's
like saying
$10.
That's like saying
enough.
because I have a membership, I can go free to the gym. It's not free. You're just paying monthly.
I can still fit.
We need to put to all
It says
coplanar
in the plane.
lines that pass through the intersection.
It says.
It says in the plan. Okay, so I just copied it down wrong.
I
So
will take
I'll
the
give you a
point.
point, but it's a formatting error for me.
But then that means I get a point as well for catching your mistake.
No, I caught his mistake also when he was talking.
But I got it. I got it like I still got it.
You still got it, McKinley. Don't let anybody tell you don't have it.
You still got it, Madonna.
Well, she doesn't have it.
I know. You're saying the same thing.
Pop stars do not age well.
Right. That's I
But
was just, I
why?
was just
What
saying.
purpose?
there's a
Why do
certain
they always?
Name me any popular song from the 1940s.
1940s.
That's what I'm saying.
Ooh.
Things that are popular don't have
Time.
longevity. I guarantee you I could name you a couple songs that were not popular songs that you can still remember. But anything that's truly what quote unquote pop, it doesn't last. You know? You're lucky if you get 30 years, if, let alone 50.
But the Macarena's been around since the 80s.
Yeah, so that's 30, 40, 80s. I thought it was the 90s.
It might be the
Right, so that's
There's a
30
lot of
years.
90s songs
Yeah.
that are still.
90s. Yeah, it's
There's
still kind of-
few, right? But
And
as the
some
years go by,
80s.
like I said, name any song from the 40s. The 50s, you might be able to
Well,
name.
the 40s was 80 years ago.
That was a rumor.
I know, that's my whole point. The only thing that lasts is classical music, opera. There's a few things, but like I said, give me something from the 1880s, 1890s, 1900s, 1910s.
I can't give you something
1422.
from the 1880s.
What?
Classical music. Like.
Well, that's my point. I'm just saying nothing popular music tends to last.
What about the 1420s? Has there been anything out
Well,
of that?
I'm not. You got to ask Miss Boyd about Bach and Beethoven, but I don't know their specific years. But that was what we were talking about.
Yeah,
Yeah.
14's a little like
Too early?
Yeah.
All right, last one.
This is a formally written proof.
When they're colored like this, guess what?
They're 3D.
They're 3D.
3D.
So you're talking about somebody made a paper airplane. It's sitting on top of plane X. Okay. And it's hard to see. You can see the little dashed lines right here. The 3D ones are the hardest ones. Okay. So we're supposed to prove that PA is congruent to PV. So basically, the two edges of the wings are congruent to each other.
Okay.
It should say that OB and OA are coplanar with plane X. It should say that.
Okay.
You kind of get that impression from the picture,
Wait, so
but it's not perfectly
Does
clear.
that mean we can't prove it because none of it's clear?
It's not perfectly clear.
Well,
It does say that PO is perpendicular to the plane, so that means that O is the intersection point, but nowhere does it say A and B are on the plane. And it could be lifted off from the. This is my own problem. This is from the book, by the way. But we're gonna assume that it is. All right. So
okay, PO is perpendicular to OB and PO is perpendicular to OA.
okay. So we got the given. Hold on. Let me catch up. There's the given. Well, what else can we say? Oh, the given says that OA is congruent to BO.
Okay, then I can solve it.
What else?
So then that both angle O's are 90 degrees
Why?
because of perpendicular lines.
So what do we need to write?
So definition of perpendicular line.
But what do we need to write?
AOP is congruent to BOP.
Probably you need one more statement before
Equals
that.
90.
Yeah,
Okay.
what he
Okay.
said.
PO is congruent to OA, and PO is congruent
No,
to OB.
even before that. What he said.
Equal 90.
The angle, because it's perpendicular, doesn't say that it equals 90, right? That's part of the definition of being perpendicular. So we need to start off by saying that, well, those two angles are 90, right?
Yeah.
By,
Definition of perpendicular.
okay, so therefore, if they're 90, what can we say about the two angles?
Then they're congruent.
Okay, so that's, okay,
So then we have,
cheap shop, but that's what we got to do. Lexu,
and then you get SAS.
and then we get
SAS.
SAS.
And then we get
Oh.
PA is congruent to PB because of CBCTC.
Can you say that any faster?
I can, yes, I can say that faster. PA is congruent to PB because of CBCTC. How about that?
All right. So let's see. PAO is congruent to PBO or something like that. Therefore, the two parts. Let me see if I got it right there. PAPD. Yes, I got that one right. Okay. There you go.
Yay.
So that one wasn't too bad. And that's it. Done. So the big idea is 2 of them today. To show that parts are congruent, you basically 2 triangles are congruent, CPCTC. Or to show that things are parallel, 2 triangles congruent, show that those parts that give you either, and it will almost always be alternate. There's might be 1 or 2 that we don't use alternate interior angles. We'll talk about that. All right, that's it.
Can I go home for the day now?
Yeah, in about 2 minutes. Ben, any questions?
No. Other than
All right,
that,
have a good weekend, Ben.
It is officially.
you too.
I'll have your test graded Saturday,
What?
so that I can now see your first page.
Oh, yes. Okay. Goodbye.
All right, no worries.
Graded